continuing with part 2 of IP addressing fundamentals, our objectives will be to determine number of bits borrowed in subnetting, calculate number of subnets, host addresses, and usable addresses, and also identify subnet ranges or host address ranges. Ending with default subnet mask. Every IP address must be accompanied by a subnet mask. For your computer to determine the network and subnet portion of an IP address, it must be ANDed the IP address with the subnet mask. Example, we have an IP address of 192.100.10.33. Now in our mind, we can directly identify this one based on our previous discussion on the class where it belongs, and which portion of the IP address is the network and the host. But our computer will not be thinking like that. So in order for your computer to get the same information, it must AND the IP address with the subnet mask in binary numbers. So here we have the IP address 192.100.10.33 converted into binary numbers, and the default subnet mask 255.255.255.0. So if you are going to AND this one, the one on the first octet, the second, and the third octet will be your network, and the one with the 0 octet, all in zeros, will be your host ID. So ending with the default subnet mask allows your computer to figure out the network portion of the address. Subnet and broadcast addresses. So in each IP network, two host addresses are reserved for special use: the subnet or network address and the broadcast address. Neither of these addresses can be assigned to an actual host, so we don't use the subnet address and the broadcast address as an actual host or a usable host. The subnet address is used to identify the network itself. A routing table contains a list of known networks, and each network is identified by its subnet address. Subnet addresses contain all 0 bits in the host portion of the address, while the broadcast address identifies all hosts on a particular network. A packet sent to the broadcast address will be received and processed by every host on that network. Broadcast addresses contain all 1 bits in the host portion of the address. So how do we determine the number of subnets and the number of hosts per subnet? The formula can be provided with this basic information. If you are going to calculate the number of subnets, you're going to use 2 to the s. And the number of usable hosts per subnet is 2 to the h minus 2, where h is the host. For the previous formula, s is the subnet. So example, we have a class A network 10.0.0.0 and has a custom subnet mask of 255.255.248.0. So what are we going to calculate here? How many new networks were created based on the custom subnet mask, and how many usable hosts are there per network? So in our example, by default, IP address 10.0.0.0 network is a class A, so that means the default subnet mask is 255.0.0.0. So to determine the number of bits stolen, we will convert the default subnet mask into a binary number, and also the custom subnet mask given in the problem into a binary number. So as you can see, in the default, comparing the default and the custom subnet mask, there are zeros in the columns that has become a 1 in the custom. So that means the ones in the custom subnet mask are the ones that are stolen bits. So clearly, there are 13 bits that have been stolen to create a new subnet mask, because this is also a subnet mask. So here, on the second octet up to the third, with the last one, is the new subnet mask bits stolen. So how many is this? It's 13. So that means 2 to the s, which is 2 to the 13, the number of subnets or the stolen bits, is equal to 8,192 new networks created. Now, after the ones in the custom subnet mask, then you have the zero. So these zeros will determine the host, the usable host. So we have 11 bits. So 2 to the 11 minus 2, which is equal to 2048 minus 2. And that is 2046 usable hosts per network. Why we have subtracted 2? Because of the subnet address and the broadcast address. Another example we are going to consider is a network Class C with IP 192.168.254.0. For example, we assume a minimum of 10 new networks required. So from here, if the new network number of networks is required, then we can calculate the number of bits stolen here based on this formula 2 to the n. So the n identifies the number of bits to steal from the host in order for us to calculate the new networks. So here, this one is from class C. So the default subnet mask is 255.255.255.0. Now, because we need 10 new networks, n will determine the number of bits to steal so that we know if it meets the requirement, which is 10 new networks. So if n is 1, this is equal to 2. If n is 2, this is equal to 4. If n is 3, this is equal to 8. But we need 10. So the next higher number is 4. So we have 16. That means there are 16 new networks created. So if that is the case, then we are going to have 4 bits stolen from the subnet mask 255.255.255.0. So since the subnet mask must be always contiguous with, that is skipping bits is not allowed. So we are going to continue from the third octet up to the fourth octet with the 4 stolen bits. That means we are going to make the 0 into a 1. So that means that our custom subnet mask is 255.255.255.240. Another example given, the number of needed subnets is 14, the number of needed usable hosts is 14, and the network IP address is 192.10.10.0. So what are we going to calculate here? What is the fourth subnet range? So this time we are going to calculate the host address range or subnet address range. So this one is a subnet address range. Then we have the 8th subnet, the 13th broadcast address for the 13th subnet, and the assignable addresses for the 9th subnet. So here, first thing that we're going to do is we're going to calculate the address class or identify. This is a class C. Then the default subnet mask is, since it is a class C, is 255.255.255.0. Now for the custom subnet mask, this is 255.255.255.240. How did we calculate this one? Then we have to identify how many bits were stolen based on these 14 needed subnets. So we can go back to the previous example and we are able to calculate this one. Then the total subnet number of subnets is 16 and the total number of hosts is also 16 because with this problem there will be 4 stolen bits. And the number of usable addresses, which is 2 to the h minus 2. So that means 16 minus 2, which is 14. And of course, the number of bits borrowed is 4. So continuing with our solution, now we know that this is our network address. So now we are going to identify the range. Okay. So for the range, there are, remember, 16 new subnet addresses that we are able to generate. So here we have 0, 1, 2, 3, 4, 5 up to 15. These are the 16 subnets or the network addresses, excluding this one. That for the host, so we start with, remember that there are 16 host addresses. So we start with 0. So our IP address will start 192.10.10.0 up to 15. This is on the first subnetwork. Okay. On the next subnetwork, another 16 hosts that is able to occupy. So we have 192.10.10.16 up to 31, and so on and so forth. So the question is, what is the fourth subnet range? So subnet range, that means the fourth, so we are going to have 1, 2, 3, 4. So this is our subnet range. 192.10.10.48 up to 192.10.10.63. What is the subnet number for the eighth subnet? So for the eighth subnet, we have 192.10.10. This one is 112 here. And then, what is the subnet broadcast address for the 13th subnet? So the broadcast is the one here on the end. Okay, so 192.10.207. And what are the assignable addresses for the ninth subnet? So the ninth subnet is here. Remember that this is assignable or usable. So the first and the last cannot be used as a usable host or assignable host. So we have to exclude that 128. So we start with 129 up to 142, excluding that 143 address. Thank you, and that's the end of part 2.